Deep in the inky blackness, somewhere between the stars, a ghost story is written not with words but with ice and time. This is not a tale of spectral figures but of a planet, our planet, that vanished. A world of blue water and green life, swallowed whole by an endless, silent winter. For 60 million years, a silence so profound fell upon the world that from the outside, Earth looked like a frozen tomb, a brilliant white orb gleaming in the cosmic dark. Yet, beneath that blinding armor, something refused to surrender. Tonight, on Hollow Terror, we will drift back to a forgotten age where life whispered its defiance against a catastrophe that should have erased it forever. Tonight on Hollow Terror, we will drift back to a forgotten age where life whispered its defiance against a catastrophe that should have erased it forever. We'll uncover how fire from within saved the world from the cold without, and how the impossible survival of a few tiny microbes laid the very foundation for everything that followed, including us. Prepare yourselves and let your mind journey softly into the heart of the Great Freeze. Our journey back across a vast and silent ocean of time begins now. We're not going back to the age of the dinosaurs or even the first fish or plants. No, our destination is far, far older. We are traveling more than 700 million years into Earth's past, to an era so ancient it feels like a different planet. Entirely, if we could somehow stand on the Earth in this forgotten age, we wouldn't recognize it. The continents weren't arranged in any familiar pattern. Instead of the 7 land masses we know, they were all welded together into a single, colossal supercontinent called Rodinia. Imagine a vast, rocky expanse stretching across the globe, its interior a desert, its edges battered by a strange and alien sea. There were no mountains with snow-capped peaks, no winding rivers, and no lush forests. The land was barren, windswept, rocky, and almost completely lifeless. If you looked closely, you might see thin, slimy mats of algae or lichen clinging to the wet edges of rocks, but that was it. The land was empty, waiting for a kind of life that had not yet evolved. Everywhere you looked, the world would have felt quiet. The rhythmic sound of waves would have been different, for these were not the blue seas of today. They were alien realms filled with strange chemistry and primitive creatures. All the richness of existence was still locked away in the oceans. Microbes and simple algae ruled the waters, drifting in massive numbers. Their tiny, single-celled bodies stained the seas with faint hues of green and red. These were the architects of Earth's early atmosphere, the slow, unseen workers who had begun releasing oxygen into the air. Yet, for all their importance, they were fragile and vulnerable, living on the thin edge of what their environment allowed. The planet was teetering on the edge of instability. For millions of years, deep beneath the crust, molten forces stirred. The tectonic plates creaked and shifted, tugging at the seams of the giant supercontinent until it began to tear apart. Cracks opened slowly, like wrinkles spreading across stone, until entire fragments of Rodinia drifted into the sea. This slow breakup of the supercontinent had profound effects on Earth's climate. The shifting land altered ocean currents, the winds that carried moisture, and the balance of gases in the air. All of these changes quietly pushed the planet closer to disaster, like a delicate scale tipping grain by grain. The breakup of Rodinia exposed vast stretches of fresh, new rock. And those rocks eagerly pulled a gas, the very gas that had kept the planet warm, from the atmosphere. This gas, carbon dioxide, CO2, is a powerful greenhouse gas. Every mountain ridge, every new coastline became a silent vacuum, drawing down the greenhouse gases that had kept the planet warm. Bit by bit, the air lost its ability to hold the sun's heat. The more the continents fractured, the more carbon was trapped away, and the cooler the planet became. This cooling did not happen in a single moment. It unfolded slowly, almost invisibly, across millions of years. But the effect was cumulative, like a long breath being drawn out of the atmosphere. The oceans themselves responded, changing their chemistry and altering how currents moved heat around the globe. Even the clouds shifted, becoming brighter and reflecting more sunlight back into space. These countless small changes worked together, nudging the Earth closer to a threshold that, once crossed, could not be undone. The planet was entering a dangerous game, one where a small push could set off a cascade of consequences. In this precarious state, the seeds of a coming catastrophe were sown. The continents were drifting apart, the seas were ruled by microbes, and the atmosphere was slowly being stripped of its greenhouse blanket. All of these forces combined into a planet quietly preparing for one of the most extreme transformations in its history. A transformation that would soon bury the equator in ice and silence the oceans under a frozen lid that stretched across the world. The world before the freeze seemed calm on the surface, but deep within, forces were gathering that would change everything forever. The key to understanding the coming catastrophe lies in a silent chemical reaction that has profoundly shaped Earth's climate for billions of years: rock weathering. This isn't just erosion, it's a process where fresh rock, water, and carbon dioxide, CO2, from the air are all consumed. The CO2 gets chemically locked away, turning into minerals that are then washed into the oceans and buried in the seafloor. Normally, volcanoes release CO2 into the air, and rock weathering pulls it back out, creating a stable, long-term balance that keeps the planet's temperature just right. But during the age of Rodinia's breakup, that balance was completely thrown off. As the supercontinent cracked and separated, immense new stretches of rock were exposed to the elements. Entire fault lines, once hidden, became open to weathering. Imagine the scale: thousands upon thousands of miles of fresh, raw rock suddenly available to absorb carbon dioxide. The Earth's thermostat went haywire. The rate at which CO2 was being pulled from the atmosphere far outpaced the rate at which it was being released by volcanoes. It was a one-way transfer, with a vast amount of greenhouse gas disappearing into stone. The air was slowly, almost imperceptibly, being stripped of its warmth. Carbon dioxide is a powerful greenhouse gas. It works like a blanket, trapping heat from the sun and keeping the planet warm enough to sustain liquid water. When you remove that blanket, the heat escapes into space and the planet cools. As the concentrations of CO2 in the atmosphere dropped, the planet became more vulnerable. The sun itself was also part of this problem. In that ancient age, our sun was about 6% fainter than it is today. This may not sound like much, but it meant that Earth was already on a razor's edge. Without a robust greenhouse blanket, the faint sunlight wasn't enough to keep the planet warm. It was a perfect storm of geological and astronomical events. The continents moved in just the right way to create a global cold snap, and the sun was already too weak to stop it. The effects were subtle at first. You wouldn't have felt a sudden drop in temperature. It was a slow, creeping chill that unfolded over millions of years. Glaciers began to thicken at the poles, sea ice expanded, and more of the planet's surface became white. This whiteness was crucial because it created a new feedback loop, a vicious cycle that made things even worse. The more ice and snow that covered the Earth, the more sunlight was reflected back into space. This is a concept known as albedo. White surfaces have a high albedo, meaning they reflect light rather than absorbing it. So, as the ice spread, the planet reflected more of the faint sunlight, making it even colder. This colder temperature, in turn, allowed the ice to spread even further. The planet was entering a runaway spiral. What began as a small shift in carbon dioxide levels caused by the breakup of a continent was amplified by the spread of ice. The gentle hum of the planet's climate system had been replaced by a quiet, relentless descent into cold. The Earth, once a relatively stable world for life, was now being pushed toward an extreme state. The delicate balance was gone, replaced by a destructive feedback loop that would not stop until it had wrapped the entire planet in an unbreakable prison of ice. The stage was set. The first act of the greatest environmental catastrophe in Earth's history had begun. The first real signs of the coming catastrophe were not felt everywhere at once. The silent advance of the cold began at the poles, the most vulnerable parts of the planet. Imagine the Earth's poles in that ancient time. They would have been cold, but not locked in permanent ice. There would have been seasonal snows and perhaps small glaciers. But as the atmosphere lost its ability to hold heat, these glaciers didn't melt as they used to. They thickened, pressing outward and downward, their edges carving icebergs into the cooling seas. Snow fell more often, and the snow that fell stayed frozen instead of melting away with the seasons. It was a subtle change at first, but the effects were cumulative and irreversible. This is where the catastrophic feedback loop, the albedo effect, truly took hold. White surfaces reflect sunlight. Think of how a black shirt feels hot in the sun while a white shirt stays cool. The same principle applies to the entire planet. As the polar ice caps expanded, more of Earth's surface became a gleaming mirror. The white surfaces of the growing glaciers reflected a greater percentage of the sun's light back into space, rather than absorbing it as the dark oceans and barren land had. This meant that less energy was being absorbed by the planet, which in turn caused temperatures to drop even further. The colder it got, the more ice formed. The more ice formed, the more sunlight was reflected away. It was a runaway spiral, a self-reinforcing cycle that was almost impossible to stop. The ice began to creep relentlessly from the poles toward the mid-latitudes. What had once been a temperate zone where simple microbes and algae thrived in warmer conditions now shivered under sheets of frost. The planet was losing its ability to regulate its own temperature. The cooling didn't happen in a single, sudden blizzard. It was a slow, agonizing descent that stretched across millennia. Century after century, the frozen edges spread farther and farther, swallowing up one region after another. The planet's climate zones began to disappear, compressed by the encroaching cold. The most chilling moment came when the glaciers crossed a critical threshold, a point of no return. Once the ice reached about 30 degrees latitude, the equivalent of what is now the southern United States or northern Africa, the cycle of cold became unstoppable. The surface area of the ice was now so vast that the albedo effect overwhelmed every other warming force. There was simply no way for the weak, ancient sun to heat the planet enough to melt the ice. From this point on, the cold was absolute and inevitable. Imagine the tropics, the lush belt of warmth that circles the middle of the Earth, transformed into a land of ice. Imagine jungles erased, shorelines turned to frost, and beaches buried beneath glaciers miles thick. The equator, a place we associate with heat and abundance, began to resemble Antarctica, silent and frozen, a place of relentless cold. It would have been a slow-motion catastrophe unfolding over millions of years. Yet, to the life that depended on stability, it must have felt sudden and terrifying. Microbes that had lived in sunlit waters found themselves cut off from light. Whole ecosystems that had balanced delicately on warmth and moisture now faced a creeping death as their world hardened around them. The Earth was slipping slowly but surely into a prison of frost, a fate from which it seemed there could be no escape. The collapse had begun, and with every passing century, the world moved closer to total silence. As the ice spread from the poles, swallowing coastlines and creeping steadily toward the tropics, the planet's greatest reservoirs, its oceans, began to change in ways that life had never faced before. The Earth's watery heart, which had pulsed with life for billions of years, was about to be put into a deep, frozen slumber. At first, it was the surface that froze. Thin sheets of ice clung to the edges of the seas. Over time, those sheets thickened, spreading wider, pressing farther out until entire oceans lay buried under a lid of frozen water. What began as fragile crusts soon grew into barriers of ice so thick they could entomb the seas beneath them. Imagine standing on the shore of what had once been a vast open ocean. Instead of rolling waves and the crash of surf, there is only silence. The water has become a frozen plain, stretching endlessly to the horizon, white and glittering under a pale sun. Where ships might one day sail, there are only ridges of ice. Where tides once rose and fell, there is nothing but stillness. The sea is no longer liquid, no longer free, but trapped under miles of frozen weight. This lid of ice did more than seal away the waters. It cut the oceans off from the sky above. No sunlight could pierce through, no warmth could filter down. The delicate balance that had sustained life in the upper layers of the sea was shattered. Tiny microbes and algae, once thriving in sunlit waters, could no longer carry out photosynthesis. The green glow of life in the shallow seas dimmed, then faded until the surface waters were barren and lifeless. The silence spread down into the depths. Without photosynthesis, the very base of the food chain collapsed. Creatures that depended on the energy of the sun starved. Whole ecosystems built on fragile exchanges of light and nutrients crumbled. It was the first great mass death of Earth's biosphere, a quiet unraveling that stretched from coastlines to the deepest trenches, and still the ice advanced, indifferent and unstoppable. The Earth was entering a spiral that fed upon itself. The more the ice expanded, the more sunlight was reflected back into the void. The less sunlight absorbed, the colder the air and seas became. What had once been a stable climate was now a runaway freeze, each stage of cooling unlocking the next, each layer of ice making the return to warmth less and less possible. From space, the change would have been clear. The poles gleamed white, then the mid-latitudes, then even the tropics. The oceans shimmered with growing sheets of ice, and the continents glittered under permanent snow. Earth was slipping slowly, but surely into a prison of frost. This transformation marked a threshold. Once the oceans were locked in ice, the Earth had stepped firmly into its prison. The cascade of loss would not stop with the microbes that fed on sunlight. Larger organisms, dependent on those microbes, would starve in turn. Chains of life, fragile and interconnected, broke one after another. It was not a sudden collapse in a single instant, but a drawn-out fading, a long unraveling of the living world. The oceans, which had once carried the promise of abundance, now carried silence. With their surfaces sealed, with their light stolen, they became monuments to the fragility of life. The freeze also broke the hydrological cycle, the planet's great water engine. In warmer ages, sunlight had lifted water from the surface of the seas. Vapor drifted upward, gathering into clouds that softened the skies. Storms rolled across valleys, dropping rain that carved rivers through the land. But under the grip of global ice, this rhythm fell apart. The oceans were no longer open to the air, sealed beneath frozen lids that stretched from horizon to horizon. Without evaporation, the clouds disappeared. The skies became barren, stripped of their white veils. The sound of rain, a sound as old as life itself, was gone. Without rain, rivers dried into empty beds of ice. Lakes vanished beneath their frozen covers. The great cycle that had tied ocean to sky to land had stopped turning, as if the earth itself had lost its heartbeat. This collapse turned Earth into something unfamiliar, something that can only be described as a frozen desert. A desert is defined not by warmth, but by the absence of water, of rain, of renewal. And in this age, Earth had become the greatest desert of all, stretching across continents and oceans alike, smothered by cold instead of heat, barren not with sand, but with endless ice. And still, beneath the silence, something persisted. Tiny sparks of life continued in places unseen, deep in oceans where heat and chemistry still offered a flicker of survival. The planet's surface looked like death, but its heart had not stopped. Completely. The white marble floating in space appeared lifeless, yet hidden within its silence were whispers of defiance. With the continents buried under snow and the oceans sealed away beneath thick slabs of ice, the next great silence began to fall over the planet. This wasn't just a world of cold, it was a world of stillness, where the very pulse of Earth's life had slowed almost to a stop. Rivers that had once cut through valleys froze in place, locked into rigid channels that would never flow again. Waterfalls stiffened into curtains of ice, their spray turned into frozen daggers clinging to stone. The sound of rain, a sound as old as life itself, was gone. Clouds thinned and vanished, leaving only a pale light from the distant sun that spilled over a barren and breathless world. The sound of earth changed, the rushing of rivers, the patter of rain, the soft percussion of water meeting soil. All of it fell away. In its place there was silence, broken only by the groaning and cracking of ice as it spread its grip across continents and seas. It was a silence heavy with finality, as if the planet itself were holding its breath. Imagine walking across such a landscape. Beneath your feet, nothing but ice and snow stretching outward in every direction, reflecting the pale light in blinding sheets. The ground, no longer soft with soil or grass, but hard and brittle. Mountains, once jagged with rock and shadow, were softened by glaciers that blanketed their peaks. Valleys filled not with rivers, but with ice compressed into solid walls that cut through the land. It was a planet reshaped, remade into silence and stillness. From above, the transformation was even more striking. Earth, once painted with blues and greens and browns, had become a dazzling orb of white. From the darkness of space, it must have glimmered like a frozen pearl, gleaming brighter than ever before. But the beauty was deceptive, because beneath that white shell lay devastation. What looked radiant from afar was up close a world stripped of warmth and movement. The reflection of sunlight back into space only deepened the freeze, locking the planet into its icy prison. The equator, usually the warm belt that carried the promise of life, was indistinguishable from the poles. The entire globe was uniform, blank and blinding, with no trace of the diversity that once marked its surface. To look at Earth, then, was to wonder if it had ever truly been alive. On the continents, there was no greenery left to break the monotony. No forests whispered in the wind, no plants reached toward the sky. The land was empty, smothered in endless snow. Even the smallest streams, the trickling lifelines that once cut through stone, had frozen solid. They stood like veins without, blood, reminders of a heartbeat that had stopped. The skies above carried their own silence. Without the rise of vapor from the seas, without the rhythm of clouds forming and dissolving, there was little left to stir the atmosphere. Storms did not gather, thunder did not rumble. The air was thin, still, and colorless. For any creature, if such a creature could have stood upon this frozen earth, the experience would have been overwhelming. The glare of light reflecting off the endless snowfields would burn the eyes. The bitter cold would cut through even the deepest layers of protection. The horizon offered no comfort, no variation, only the repetition of white upon white. The very concept of seasons had vanished. There was no spring to bring relief, no summer to offer warmth, no autumn to soften the air, only winter without end. And yet, beneath the silence, beneath the stillness, something persisted. Tiny sparks of life continued in places unseen, deep in oceans where heat and chemistry still offered a flicker of survival. The planet's surface looked like death, but its heart had not stopped completely. The white marble floating in space appeared lifeless, yet hidden within its silence were whispers of defiance. The planet was no longer one of flowing rivers and singing rains. It had become a frozen monument, dazzling, stark, and quiet, its beauty masking the peril beneath. The silence was not an end, but a pause in the great unfolding story of Earth. And as the glaciers thickened and the snow piled higher, the world sank deeper into its long sleep, waiting for the next turn in its ancient rhythm. With the surface of the planet locked in ice and the oceans sealed away, it would seem that life had finally reached its end. But even in this greatest of trials, life found a way to endure. The key to survival lay in a world that owed nothing to the sun. Beneath the crushing weight of the frozen seas, deep in the blackness where sunlight had never reached even in warmer ages, there were cracks in the ocean floor. Along these cracks, water seeped into the fiery crust below and returned as jets of superheated water rising in dark plumes. These were hydrothermal vents, towers of stone and mineral that poured out warmth and chemicals from the Earth's restless interior. They were the planet's inner fire pushing back against the cold. Around these vents, tiny worlds formed. Instead of living on light, the organisms here turned to a process called chemosynthesis. Chemosynthesis is the ability to create food not from sunlight, but from chemical reactions. Microbes clustered around the vents, feeding on the rich soup of hydrogen, sulfur, and iron that poured from the vents. They built energy from these raw ingredients, weaving life out of chemistry itself. It was a miracle of adaptation, a complete reinvention of survival in the absence of light. These dark ocean floors became a network of microbial mats, thick carpets of living cells clinging to every surface near the vents. To the eye, they would have looked like slick, glowing layers of slime spreading over rocks. But within them, countless cells worked together, multiplying and passing energy along fragile chains of existence. Around these mats, other organisms found food, building entire ecosystems in the absence of light. It was an alien world, teeming with life in the complete darkness of the abyss. Not all survival was hidden in the deepest trenches. Even on the surface, though the land was smothered and the skies were barren, there were places where heat still pulsed through the ice. Volcanic activity created rare sanctuaries, pockets of warmth where the earth itself pushed back against the cold. Lava pools glowed in the frozen darkness, steaming against the glaciers that pressed around them. In such places, the ice melted into thin lakes of liquid water, and the warmth allowed tiny oases to exist. Within them, microbes huddled close, clinging to life where everything else had perished. These volcanic pools were fragile, yet they were havens. They gave life a chance to hold on, even if only in microscopic form. Life also adapted in ways that defied the harshest conditions. Some microbes developed strategies to endure the eternal night. Instead of relying on sunlight, they harvested energy from the simplest reactions of chemicals. Others slipped into dormant states, curling inward, to wait out the freeze, capable of surviving for years without activity, only awakening when conditions briefly softened. They were small, unseen, and fragile. Yet in their persistence, they were unyielding. The surface of Earth was silent. The skies were empty, the oceans locked away. But hidden deep below there was still movement. Warmth rose from vents and gases, hissed from cracks. In these places life clustered, a thin thread of existence stretched across impossible odds. The planet appeared lifeless from afar, a frozen orb gleaming white under a faint sun. Yet in its depths life clung stubbornly to volcanic heat, weaving its existence around the chemistry of sulfur and iron, whispering its defiance into the darkness. The great freeze had silenced the oceans above, but it could not silence the fire within the earth. And it was that fire that carried life through the longest night the planet had ever known. The ice did not come and go with the rhythm of seasons. It did not retreat after a few centuries or even after a few millennia. Once the earth was sealed in its frozen shell, it stayed that way for an almost unimaginable stretch of time. Scientists call this frozen age the Sturtian glaciation, and it lasted for around 60 million years. To us, 60 million years is a number so vast that it is almost impossible to hold in the mind. It is not the span of a human lifetime or of a civilization or even of our entire species. It is a stretch of time longer than the distance that separates us from the last of the great dinosaurs. For perspective, humanity has existed for roughly 300,000 years. That is a blink compared to the endless winter of the Sturtian glaciation. Every story humans have ever told, every empire ever built, every work of art or leap of science has happened within that brief span of 300,000 years. Now imagine a cold that did not relent for 200 times that amount of time. 60 million years is long enough for mountains to rise and wear down again, long enough for oceans to shift their shores and carve new coasts, long enough for entire lineages of creatures to appear and vanish. Yet through all of it, the world remained frozen, unyielding, silent. Life, such as it was, endured in that stillness, but to call it living hardly captures the reality. These organisms were trapped in a kind of stasis, surviving on the barest threads of possibility. Generations rose and fell within the shadows of hydrothermal vents, or in the rare volcanic pools that dotted the frozen landscape. Yet for each new generation, the world outside remained unchanged. Microbes were born, multiplied, and died in darkness, while above them the planet carried on as a glistening marble of ice. Imagine what 60 million years means in terms of generations. If a microbe divides every day, then 60 million years is not thousands or even millions of generations, but trillions. Entire unbroken chains of life cycling through birth and death, carrying forward the tiniest spark of existence without pause. To those microbes, the frozen world was all they knew. It is haunting to picture such a time. The surface of the world was empty, stripped of motion and sound. Yet beneath it, countless generations of life clung on, their persistence invisible to the stars. Theirs was not survival as we think of it, active and striving, but survival reduced to the simplest act of continuing, no matter how long the winter lasted. This was the longest continuous ice age in Earth's history. Never before and never since has the planet been locked for so long in one unbroken season. If you had stood on Earth at the beginning of the freeze and then somehow returned 60 million years later, you would have seen nearly the same sight. White horizons, silent glaciers, sealed seas. The microbes that clustered in those hidden sanctuaries did not know they were keeping the flame of life alive. They simply carried on, unaware that their endurance across 60 million frozen years was writing the foundation for everything that would come after. And still, beneath that weight of time, the Earth held on to more than silence. For deep within the planet, forces were still moving, volcanoes still erupted, heat still rose from cracks in the crust. Beneath the frozen surface, the story was continuing, preparing for the next great shift in the planet's history. The silence of 60 million years was not the end, but a deep, long breath before the next act. For millions upon millions of years, the Earth lay trapped in silence, its surface smothered in ice, its oceans sealed in darkness. Yet, even while the world above seemed frozen in stasis, the heart of the planet still beat with restless energy. Deep beneath the frozen crust, magma stirred, pressure built, and heat pulsed. The Earth had not gone cold inside. Fire still lived beneath the ice. Volcanoes were the scars where that inner fire broke through. They rumbled beneath the glaciers, their eruptions muffled by the weight pressing down from above. Some spewed their fury under the oceans, unseen in the black depths, releasing plumes of heat and gases into waters already starved of life. Others cracked through the frozen continents, fountains of lava forcing their way against the cold. Each eruption was a reminder that the planet was alive, even if its surface seemed lifeless. Every burst of volcanic fire released something far more powerful than molten rock. Carbon dioxide, CO2. This same gas that had kept the planet warm was now being reintroduced into the atmosphere, molecule by molecule. For as long as the ice held, the planet's rocks could no longer absorb that gas through weathering. The normal balance of carbon had been broken. With every eruption, the greenhouse gases lingered, slowly building, slowly pressing against the endless grip of the cold. Normally, the water cycle would absorb this gas and lock it away in stone. But under the frozen surface, with the water cycle broken and continents sealed, that system had shut down. The CO2 that poured out of volcanoes had nowhere to go but up, accumulating in the sky. These eruptions also brought change to the frozen surface. When lava met ice, it created pockets of warmth that seemed almost miraculous in their rarity. Glaciers hissed and steamed as rivers of molten rock slid across their surfaces. For a brief time, the cold was broken. Pools of liquid water gathered near the flows, steaming against the frozen silence, offering temporary havens. These small oases were not enough to change the global freeze, but they gave life tiny footholds, fragile sanctuaries in a desert of ice. Picture such a scene. A landscape of endless white, silent and frozen, broken suddenly by a wound of red fire. Lava spills into the cold air, its heat cracking the ice and sending clouds of steam into the sky. Around it, pools of meltwater gather liquid against all odds. To the microbes that endured, such places were salvation. Survival in this age did not come from stability, but from chaos. The ice pressed down with uniform stillness, but it was the unpredictable, violent eruptions of volcanoes that gave life its chances. Chaos created warmth. Chaos created cracks in the silence, and in those cracks life endured. The Earth, though frozen on the surface, was restless within. The return of fire beneath ice was not a constant, steady flame, but a series of bursts and spasms, unpredictable and fierce. Each eruption was destructive in its way, yet also life-giving. For without them, the ice might have been absolute. Without them, the planet might have sunk into permanent silence. Instead, the fire provided just enough chaos, just enough disturbance to keep survival possible. Over time, the gases that escaped from these eruptions accumulated. Carbon dioxide thickened in the atmosphere, invisible yet powerful. Slowly, the planet was being prepared for its eventual escape. For now, the ice still ruled, but the balance had shifted. Beneath the stillness of the frozen desert, chaos was working quietly, patiently, to tip the scales back toward warmth. The return of fire beneath ice did not end the longest winter, but it kept the flame of survival alive. It created oases where none should exist, and it laid the groundwork for the thaw to come. And so the frozen planet, seemingly lifeless, was not entirely silent. It was a world of opposites: fire against ice, chaos against stillness, survival hidden in the tension between destruction and creation. When we picture Snowball Earth, we often imagine a world completely locked in ice, a perfect, gleaming white sphere with no open water at all. This is the hard snowball theory. It envisions Earth locked under ice from pole to pole, with glaciers and frozen seas covering every inch of the planet's surface. In this version, no sunlight could reach the waters below, no evaporation could rise to form clouds, and no rivers could flow across the land. Life survived only in deep, hidden sanctuaries, near volcanic vents or geothermal oases completely cut off from the sun's energy. To stand on such a planet would have been to see nothing but endless white, the horizon swallowed in ice, the silence absolute. But there are scientists who suggest this picture may be too extreme. They argue that while most of the oceans froze, there could have been thin stretches near the equator where the ice was not as thick, or even small puddles of open water where the sun still touched the sea. In this slushball scenario, the ice still wrapped the world, but it was patchy in places, leaving fragile windows of liquid ocean exposed. Such areas would have been rare, but they might have made a crucial difference. If open waters existed, even in the smallest amounts, they would have allowed sunlight to penetrate the ocean surface, feeding tiny algae and microbes with the energy they needed. The food chain would not have collapsed as completely. Instead of life surviving only on chemical reactions in the dark, photosynthesis might have continued in hidden corners of the seas. These equatorial puddles would have been refugees of a different kind, small sanctuaries of light in a world otherwise drowned in shadow. Imagine the contrast. In the hard snowball vision, survival depended entirely on Earth's inner fire, on volcanoes, and hydrothermal vents, on chemistry replacing sunlight. Life would have been pushed to its absolute limits, barely clinging on in the smallest cracks. But in the slushball vision, survival also had the faintest help from the sun. Tiny areas of open water would have kept ecosystems alive, preserving a link to the surface world even as the planet froze. The debate between these two visions has been ongoing for decades. Both sides point to clues, yet neither can claim final proof. The presence of dropstones at the equator suggests the ice was thick, carried by glaciers that floated in seas sealed by frozen lids. But the isotope signals in the rocks show that photosynthesis never stopped entirely, which could mean life endured in cracks of ice, or it could mean sunlight still reached some scattered open waters. The rocks whisper possibilities, but they do not tell us everything. Each theory reshapes the survival story. If Earth was a true hard snowball, then life endured one of the most extreme trials imaginable, adapting to a planet where the sun could no longer reach the seas. The endurance of microbes in complete darkness, generation after generation, would be one of the greatest feats of resilience in Earth's history. But if Earth was instead a slush ball, then the story is one of fragility and luck, with life finding its way in rare puddles of open sea, depending on patches of sunlight that refused to disappear entirely. Both versions are humbling. Both remind us how precarious life was in that frozen age. Whether clinging to volcanic heat in the abyss or surviving in equatorial pools of thin water, life was pressed against the edge of extinction, yet refused to let go. The difference lies in how narrow that edge was. The truth may never be fully known. Perhaps the Earth shifted between both states, at times a hard snowball locked in suffocating silence, at other times a slush ball offering fleeting windows of open water. What we do know is that however the details unfolded, survival was never easy. Every life that endured did so against unimaginable odds, carrying forward the fragile story of existence into the ages that would follow. The end of the Sturtian glaciation was not the end of Earth's trials. After 60 million years of silence and ice, the planet slowly began to thaw. Volcanoes had poured carbon dioxide into the atmosphere for so long that eventually the greenhouse effect overwhelmed the reflective power of the ice. Glaciers retreated, oceans reopened, and sunlight returned to the waters, feeding photosynthesis once again. For a time, it must have seemed as though the nightmare was over. But the Earth was not finished with its deep freeze. Barely 10 million years after the thaw, the planet slipped once again into a global glaciation. Scientists call this second catastrophe the Marinoan glaciation, and it lasted for around 15 million years. While shorter than the Sturtian, it was still a span so vast that it dwarfs all of human history many times over. This was not a passing relapse. It was another apocalypse, complete in its reach, with ice once again encasing the world from pole to equator. Why would Earth endure not one but two such frozen imprisonments in such close succession? The answer lies in the delicate balance of the planet's climate system. When the Sturtian ended, the atmosphere was thick with greenhouse gases, enough to tip the planet back toward warmth. But in the chaos that followed, the cycle of weathering and carbon capture began again. The newly exposed rocks of the continents eagerly pulled carbon dioxide from the sky, dragging the atmosphere back toward fragility. Slowly, the greenhouse blanket thinned once more, and with each molecule removed, the planet edged closer to collapse. Eventually, the scales tipped, and the cycle repeated. The Marinoan glaciation was, in some ways, even more dramatic than the first. The layers of stone that record its passing show thick bands of glacial deposits just like those of the Sturtian, but with subtle differences that tell of shifting conditions. Dropstones are once again found from where they should be, proving that glaciers reached into the tropics a second time. The chemical signatures in the rocks once again show the fingerprints of life surviving against the odds, tiny signals of microbial activity even as the surface lay frozen. One of the most striking pieces of evidence comes from the layered rocks themselves. Imagine slicing into the Earth's crust and seeing alternating bands, one recording the silence of the Sturtian, another marking the chaos of the thaw, and then another repeating the story with the Marinoan. These bands are like pages in a book, each one written in stone, each one telling of the planet's frozen relapses. They are not gentle records, they are abrupt, thick, and global, showing that the Earth did not stumble into regional freezes, but was engulfed in total transformations. The Marinoan also left behind its own cap carbonates, marking the moment when the thaw came again. These layers sit directly on top of glacial deposits, proof of a sudden transition from ice to warmth. In some places they are so thick that they can be measured in meters, evidence of chemical reactions unleashed when the greenhouse effect returned in force. They are monuments to the violence of Earth's swings from frozen silence to sudden floods of life. To imagine two such events so close together is to realize how unstable the planet was in that age. The Cryogenian period was not a time of balance. It was a time of extremes, of violent oscillations between states that nearly destroyed the possibility of life. That life endured through one global ice age is remarkable. That it endured through two is almost beyond belief, and yet the rocks confirm it. The layers lie one atop the other, a repeating pattern of catastrophe. The Marinoan was the final act of the Cryogenian, the second plunge into silence before Earth emerged into a world transformed. These twin freezes are written into the crust, reminders that the path of life has never been smooth, but forged through cycles of collapse and survival. The second freeze was not merely an echo of the first. It was proof that the forces driving the planet were unstable, that even after tens of millions of years of ice, Earth was still vulnerable to falling back into silence. It was as if the world was testing life, pressing it again and again against the edge of extinction. And through it all, life held on, waiting for the age when the ice would finally retreat for good. When we picture Snowball Earth, we often imagine a world completely locked in ice, a perfect, gleaming white sphere with no open water at all. This is the hard snowball theory. It envisions Earth locked under ice from pole to pole, with glaciers and frozen seas covering every inch of the planet's surface. In this version, no sunlight could reach the waters below, no evaporation could rise to form clouds, and no rivers could flow across the land. Life survived only in deep, hidden sanctuaries, near volcanic vents or geothermal oases completely cut off from the sun's energy. To stand on such a planet would have been to see nothing but endless white, the horizon swallowed in ice, the silence absolute. But there are scientists who suggest this picture may be too extreme. They argue that while most of the oceans froze, there could have been thin stretches near the equator where the ice was not as thick, or even small puddles of open water where the sun still touched the sea. In this slushball scenario, the ice still wrapped the world, but it was patchy in places, leaving fragile windows of liquid ocean exposed. Such areas would have been rare, but they might have made a crucial difference. If open waters existed, even in the smallest amounts, they would have allowed sunlight to penetrate the ocean surface, feeding tiny algae and microbes with the energy they needed. The food chain would not have collapsed as completely. Instead of life surviving only on chemical reactions in the dark, photosynthesis might have continued in hidden corners of the seas. These equatorial puddles would have been refugees of a different kind, small sanctuaries of light in a world otherwise drowned in shadow. Imagine the contrast. In the hard snowball vision, survival depended entirely on Earth's inner fire, on volcanoes, and hydrothermal vents, on chemistry replacing sunlight. Life would have been pushed to its absolute limits, barely clinging on in the smallest cracks. But in the slushball vision, survival also had the faintest help from the sun. Tiny areas of open water would have kept ecosystems alive, preserving a link to the surface world even as the planet froze. The debate between these two visions has been ongoing for decades. Both sides point to clues, yet neither can claim final proof. The presence of dropstones at the equator suggests the ice was thick, carried by glaciers that floated in seas sealed by frozen lids. But the isotope signals in the rocks show that photosynthesis never stopped entirely, which could mean life endured in cracks of ice, or it could mean sunlight still reached some scattered open waters. The rocks whisper possibilities, but they do not tell us everything. Each theory reshapes the survival story. If Earth was a true hard snowball, Then, life endured one of the most extreme trials imaginable, adapting to a planet where the sun could no longer reach the seas. The endurance of microbes in complete darkness, generation after generation, would be one of the greatest feats of resilience in Earth's history. But if Earth was instead a slush ball, then the story is one of fragility and luck, with life finding its way in rare puddles of open sea, depending on patches of sunlight that refused to disappear entirely. Both versions are humbling. Both remind us how precarious life was in that frozen age. Whether clinging to volcanic heat in the abyss or surviving in equatorial pools of thin water, life was pressed against the edge of extinction, yet refused to let go. The difference lies in how narrow that edge was. The truth may never be fully known. Perhaps the Earth shifted between both states, at times a hard snowball locked in suffocating silence, at other times a slush ball offering fleeting windows of open water. What we do know is that however the details unfolded, survival was never easy. Every life that endured did so against unimaginable odds, carrying forward the fragile story of existence into the ages that would follow. The end of the Sturtian glaciation was not the end of Earth's trials. After 60 million years of silence and ice, the planet slowly began to thaw. Volcanoes had poured carbon dioxide into the atmosphere for so long that eventually the greenhouse effect overwhelmed the reflective power of the ice. Glaciers retreated, oceans reopened, and sunlight returned to the waters, feeding photosynthesis once again. For a time, it must have seemed as though the nightmare was over. But the Earth was not finished with its deep freeze. Barely 10 million years after the thaw, the planet slipped once again into a global glaciation. Scientists call this second catastrophe the Marinoan glaciation, and it lasted for around 15 million years. While shorter than the Sturtian, it was still a span so vast that it dwarfs all of human history many times over. This was not a passing relapse. It was another apocalypse, complete in its reach, with ice once again encasing the world from pole to equator. Why would Earth endure not one but two such frozen imprisonments in such close succession? The answer lies in the delicate balance of the planet's climate system. When the Sturtian ended, the atmosphere was thick with greenhouse gases, enough to tip the planet back toward warmth. But in the chaos that followed, the cycle of weathering and carbon capture began again. The newly exposed rocks of the continents eagerly pulled carbon dioxide from the sky, dragging the atmosphere back toward fragility. Slowly, the greenhouse blanket thinned once more, and with each molecule removed, the planet edged closer to collapse. Eventually, the scales tipped, and the cycle repeated. The Marinoan glaciation was, in some ways, even more dramatic than the first. The layers of stone that record its passing show thick bands of glacial deposits just like those of the Sturtian, but with subtle differences that tell of shifting conditions. Dropstones are once again found from where they should be, proving that glaciers reached into the tropics a second time. The chemical signatures in the rocks once again show the fingerprints of life surviving against the odds, tiny signals of microbial activity even as the surface lay frozen. One of the most striking pieces of evidence comes from the layered rocks themselves. Imagine slicing into the Earth's crust and seeing alternating bands, one recording the silence of the Sturtian, another marking the chaos of the thaw, and then another repeating the story with the Marinoan. These bands are like pages in a book, each one written in stone, each one telling of the planet's frozen relapses. They are not gentle records, they are abrupt, thick, and global, showing that the Earth did not stumble into regional freezes, but was engulfed in total transformations. The Marinoan also left behind its own cap carbonates, marking the moment when the thaw came again. These layers sit directly on top of glacial deposits, proof of a sudden transition from ice to warmth. In some places they are so thick that they can be measured in meters, evidence of chemical reactions unleashed when the greenhouse effect returned in force. They are monuments to the violence of Earth's swings from frozen silence to sudden floods of life. To imagine two such events so close together is to realize how unstable the planet was in that age. The Cryogenian period was not a time of balance. It was a time of extremes, of violent oscillations between states that nearly destroyed the possibility of life. That life endured through one global ice age is remarkable. That it endured through two is almost beyond belief, and yet the rocks confirm it. The layers lie one atop the other, a repeating pattern of catastrophe. The Marinoan was the final act of the Cryogenian, the second plunge into silence before Earth emerged into a world transformed. These twin freezes are written into the crust, reminders that the path of life has never been smooth, but forged through cycles of collapse and survival. The second freeze was not merely an echo of the first. It was proof that the forces driving the planet were unstable, that even after tens of millions of years of ice, Earth was still vulnerable to falling back into silence. It was as if the world was testing life, pressing it again and again against the edge of extinction. And through it all, life held on, waiting for the age when the ice would finally retreat for good. The Earth of the Cryogenian did not orbit beneath the same sun we know today. Our star, though steady and constant in its daily rise and fall, has been changing over deep time. Billions of years ago, it was weaker, shining with less intensity, pouring down less energy onto the planet below. This puzzle is known as the faint young sun paradox. By all calculations, a weaker sun should have left the Earth frozen solid from the very beginning. And yet life arose and flourished long before the great ice ages of the Cryogenian. Something, perhaps, greenhouse gases like carbon dioxide and methane must have kept the Earth warm enough to remain habitable, but that fragile protection did not last forever. When the gases began to slip away, the dimmer sun revealed just how vulnerable the planet really was. Imagine the warmth of sunlight not as a blazing force, but as a thin and delicate thread stretched between the heavens and the Earth. During the Cryogenian, that thread was already weaker than it is today. The light that reached the surface was fainter by a few percent, and in the balance of climate, those few percent made all the difference. Even slight changes in the way the atmosphere trapped heat, or in the way the oceans absorbed energy, could send the system tilting toward catastrophe. The seesaw of climate, already precarious, had lost much of its counterweight. Under this dimmer starlight, the Earth became far more vulnerable to freezes. Once ice began to spread, the weak sun could not fight back. White surfaces reflected its light away, bouncing precious warmth back into space. The colder the planet grew, the harder it became for the sun to push against the advancing silence. The faint young sun was steady in its light, but it was not enough. Without the greenhouse gases to hold in heat, the energy slipped away into the void, and the planet sank deeper into its frozen state. From a cosmic vantage point, this transformation would have been striking. Picture Earth as seen from space, not the blue and green jewel we know, but a dazzling sphere of white, gleaming brighter than any neighboring world. To an observer drifting beyond the solar system, Earth would have looked lifeless, its oceans invisible beneath miles of ice, its continents indistinguishable under glaciers. It would have resembled the frozen exoplanets we now discover orbiting other stars, worlds dismissed as barren because they appear locked in ice. It is humbling to realize that our planet once looked so dead from afar. If another civilization had peered across the light years and studied Earth in that age, they might have turned away, convinced it was sterile, incapable of harboring life. And yet, hidden in the cracks of volcanic heat, in the dark of the oceans, in rare pockets of survival, life endured, unseen and unsuspected. Earth wore the face of a frozen exoplanet, but its story was not over. The faint young sun paradox lingers even in our imagination. It forces us to think of the balance that made life possible as razor-thin, held together by invisible forces that can be lost with the smallest change. Greenhouse gases saved the early Earth, wrapping it in a blanket strong enough to compensate for the sun's weakness. But once that blanket was stripped away by weathering and by the breakup of continents, the faint sun was powerless to prevent the descent into ice. This cosmic perspective reveals something haunting. From the scale of space, planets may appear dead when they are alive, or alive when they are near death. A frozen sphere may still whisper with survival beneath its surface. A bright blue marble may hide fragility within. In the age of Snowball Earth, our planet lived a double life, dazzling and lifeless to the eye, yet breathing in hidden places no telescope could see. The image of Earth as a white exoplanet drifting under a weaker sun is both beautiful and unsettling. It reminds us how easily our world could have remained that way, locked forever in silence, overlooked by the cosmos. The same faint starlight that nourished survival also exposed how vulnerable life truly was. And while the Earth glistened as a frozen pearl in the dark, the story within continued, waiting for the fire and the gases beneath the ice to tip the balance once more toward warmth. The long stillness had ended. The Earth, which had been locked in ice for tens of millions of years, stirred from its deep slumber. A quiet transformation was building deep within the atmosphere, as volcanoes, relentless and patient, spewed carbon dioxide, CO2, into the air. With no liquid water or weathering rock to absorb it, the gas built up in staggering amounts. This slow accumulation of greenhouse gases was the planet's only chance. Eventually, the tipping point arrived. The balance that had once sent the world, spiraling into cold, now leaned the other way. The greenhouse gases had grown so dense that the faint energy of the sun could no longer escape into space. Heat began to gather, small at first, barely enough to soften the edges of glaciers, but over time it built with relentless persistence. The white marble that had reflected the sun's light so efficiently could no longer hold back the warming. Cracks appeared in the frozen silence. Once the first fractures opened, the change came quickly. Melting spread across the surface, and water pooled on top of the glaciers. Those pools absorbed sunlight instead of reflecting it, warming faster, cutting deeper into the ice. What had once been solid and unyielding began to collapse under its own weight. Rivers of meltwater carved their way through the frozen plains, burrowing downward until they reached the seas below. The oceans, locked beneath ice for 60 million years, were suddenly exposed. Great slabs of ice shattered and slid into the water, breaking apart with thunderous cracks that echoed across the continents. Where once the seas had been still and black, now floods of melt poured into them, stirring their layers, mixing ancient waters with sudden torrents of fresh runoff. The silence of ages was broken by chaos. The scale of the thaw is almost impossible to imagine. The glaciers that covered the continents were miles thick. When they collapsed, they released floods greater than anything seen since. Entire landscapes were drowned beneath surges of water. Valleys were scoured clean by torrents that carved new paths across the land. The weight of ice that had pressed down on the continents for millions of years lifted, and the Earth's crust rebounded, reshaping mountains and coasts. It was a planetary flood, not in myth or legend, but in stone and water. A deluge measured, not in years, but in cataclysmic bursts that remade the face of the earth. In the oceans, the consequences were equally dramatic. Waters that had been sealed in darkness for eons were suddenly stirred by sunlight. Icebergs fractured and drifted, releasing vast amounts of trapped minerals into the sea. The chemistry of the oceans shifted almost overnight, transforming them from stagnant and lifeless basins into dynamic systems ready to feed the resurgence of life. Where once there had been only silence, now there was motion, mixing, and chaos. Imagine standing at the edge of one of these landscapes. As the thaw began, walls of ice taller than mountains collapse in slow, thunderous cascades. Rivers roar where none had flowed for tens of millions of years. Floods tear across plains, churning soil, stone, and water into torrents that reshape valleys in moments. The air itself grows heavy with moisture again, clouds gathering as evaporation returns. Rain falls for the first time in ages, washing the barren land, filling new rivers, and feeding the reborn water cycle. It was not a gentle return. The thaw was violent, destructive, and absolute. Yet it was also the beginning of renewal. The greenhouse gases that had saved the Earth from permanent silence now unleashed a transformation that could not be stopped. The planet was pulled from its icy tomb and set once again into motion. Life, which had hidden in the smallest corners, would soon feel the consequences of this flood. The long stillness had ended, and the stage was being set for an explosion of change unlike anything the Earth had seen before. The long stillness had ended. The Earth, which had been locked in ice for tens of millions of years, stirred from its deep slumber. A quiet transformation was building deep within the atmosphere as volcanoes, relentless and patient, spewed carbon dioxide, CO2, into the air. With no liquid water or weathering rock to absorb it, the gas built up in staggering amounts. This slow accumulation of greenhouse gases was the planet's only chance. Eventually the tipping point arrived. The balance that had once sent the world, spiraling into cold, now leaned the other way. The greenhouse gases had grown so dense that the faint energy of the sun could no longer escape into space. Heat began to gather, small at first, barely enough to soften the edges of glaciers, but over time it built with relentless persistence. The white marble that had reflected the sun's light so efficiently could no longer hold back the warming. Cracks appeared in the frozen silence. Once the first fractures opened, the change came quickly. Melting spread across the surface, and water pooled on top of the glaciers. Those pools absorbed sunlight instead of reflecting it, warming faster, cutting deeper into the ice. What had once been solid and unyielding began to collapse under its own weight. Rivers of meltwater carved their way through the frozen plains, burrowing downward until they reached the seas below. The oceans, locked beneath ice for 60 million years, were suddenly exposed. Great slabs of ice shattered and slid into the water, breaking apart with thunderous cracks that echoed across the continents. Where once the seas had been still and black, now floods of melt poured into them, stirring their layers, mixing ancient waters with sudden torrents of fresh runoff. The silence of ages was broken by chaos. The scale of the thaw is almost impossible to imagine. The glaciers that covered the continents were miles thick. When they collapsed, they released floods greater than anything seen since. Entire landscapes were drowned beneath surges of water. Valleys were scoured clean by torrents that carved new paths across the land. The weight of ice that had pressed down on the continents for millions of years lifted, and the Earth's crust rebounded, reshaping mountains and coasts. It was a planetary flood, not in myth or legend, but in stone and water, a deluge measured, not in years, but in cataclysmic bursts that remade the face of the Earth. In the oceans, the consequences were equally dramatic. Waters that had been sealed in darkness for eons were suddenly stirred by sunlight. Icebergs fractured and drifted, releasing vast amounts of trapped minerals into the sea. The chemistry of the ocean shifted almost overnight, transforming them from stagnant and lifeless basins into dynamic systems ready to feed the resurgence of life. Where once there had been only silence, now there was motion, mixing, and chaos. Imagine standing at the edge of one of these landscapes. As the thaw began, walls of ice taller than mountains collapse in slow, thunderous cascades. Rivers roar where none had flowed for tens of millions of years. Floods tear across plains, churning soil, stone, and water into torrents that reshape valleys in moments. The air itself grows heavy with moisture again, clouds gathering as evaporation returns. Rain falls for the first time in ages, washing the barren land, filling new rivers, and feeding the reborn water cycle. It was not a gentle return. The thaw was violent, destructive, and absolute. Yet it was also the beginning of renewal. The greenhouse gases that had saved the Earth from permanent silence now unleashed a transformation that could not be stopped. The planet was pulled from its icy tomb and set once again into motion. Life, which had hidden in the smallest corners, would soon feel the consequences of this flood. The long stillness had ended, and the stage was being set for an explosion of change, unlike anything the Earth had seen before. Even as the oceans surged back to life with oxygen and movement, the scars of the Great Freeze were not easily erased. 60 million years of deep cold during the Sturtian glaciation, followed closely by another 15 million during the Marinoan, had pushed life to its absolute limits. Entire lineages that had once drifted in the seas were gone forever, extinguished by the endless night. What remained was a planet populated not by abundance, but by survivors, a thin thread of existence carried forward by those who had endured. In the darkest corners, populations had collapsed to tiny remnants. Microbes that once spread widely across the oceans were forced into a handful of refugees, clinging to hydrothermal vents, geothermal pools, or perhaps in the thinnest stretches of equatorial seas if open water ever existed. These survivors were not vast and varied communities. They were reduced to slivers of diversity, narrow strands of DNA passed down generation after generation through billions of cell divisions. The entire tree of life had been trimmed back to its barest branches. This reduction is what scientists call a genetic bottleneck. When most of a population is lost, only a small fraction of its genes carry forward. In normal times, diversity allows life to adapt in many directions at once. But in a bottleneck, diversity shrinks and the survivors are forced to adapt with whatever traits remain. The danger is obvious. With too little variety, a single catastrophe could wipe everything out. Yet paradoxically, bottlenecks can also create resilience. They strip away the fragile, the vulnerable, leaving behind organisms hardened by the extremes they endured. Imagine those microbes multiplying in their tiny sanctuaries. For millions upon millions of years, every cell that survived had to tolerate crushing cold, total darkness, or toxic chemical environments. Those that could not adapt disappeared. Those that could persisted, carrying their traits forward. Over time, this relentless filtering forged resilience. The DNA of survivors carried instructions for endurance, for flexibility, for life at the very edge of possibility. It is humbling to realize how close everything came to ending. The world as we know it, with forests, animals, and humans, is built upon that narrow survival. If the bottleneck had been tighter still, if the refugees had failed, the story of life might have ended with microbes frozen in the dark. Instead, those survivors endured long enough for the thaw to arrive, and with it, an explosion of possibilities. Hardship, in this sense, became the mother of innovation. In the wake of the bottleneck, life did not simply return to what it had been. It began to experiment. Stripped down to its core, pushed by the demands of survival, life found new ways to grow. The simplest organisms began forming more complex structures, linking together in cooperation. Cells that had endured alone started to specialize, to share, work to create the first steps toward multicellularity. The trials of the deep freeze had primed them for change. The bottleneck did not just preserve life, it prepared it. What followed would be one of the most dramatic transformations in the history of the planet. The rise of complex life, the blossoming of diversity, the path that would one day lead to animals, plants, and eventually us. Yet all of that depended on these tiny survivors huddled in volcanic shadows, whispering against extinction, carrying the story forward when almost everything else was lost. The Earth had pressed life against the edge, reducing it to remnants, narrowing its possibilities, testing its endurance. And in that crucible, resilience was born. Out of the silence of the Snowball Earth came not only survival, but the seeds of the next great leap forward. The Great Thaw did more than just end an age of ice. It opened the door to one of the most remarkable chapters in the history of life, the Cambrian explosion. Only tens of millions of years after the glaciers retreated, the seas that had once been silent and dark were suddenly filled with an extraordinary diversity of creatures. It was as if the world, having endured its longest winter, awoke not just to survive, but to create. Before Snowball Earth, life had been simple. For billions of years, microbes dominated the planet, shaping its chemistry and atmosphere, but never developing much complexity. They were abundant, but they were limited in form, largely invisible mats and colonies spread across the oceans. But after the thaw, something shifted. The fossil record shows that around 540 million years ago, life began to diversify at a pace never seen before. Creatures with shells, skeletons, and complex bodies appeared in a geological instant. Entire ecosystems burst into existence, filled with predators and prey, grazers and burrowers, builders and hunters. The Earth, long silent in form, had found its voice in living shapes. Why did this explosion happen when it did? Many scientists believe the ordeal of Snowball Earth played a crucial role. The extreme stress of surviving 60 million years of ice, followed by another 15 million in the second freeze, may have acted as a crucible. Those bottlenecks of survival forced life to adapt in ways it never had before. Microbes that endured had been hardened by scarcity, trained by constant struggle to make the most of every resource. When the thaw came and the oceans were suddenly rich with oxygen and nutrients, those survivors were primed to take advantage. It is easy to imagine the scene. The seas, once starved of oxygen, now surged with it as circulation returned, and photosynthesis bloomed in sunlight. Nutrients that had built up in the deep over millions of years now mixed into the surface waters. For the organisms that had survived in the shadows, it must have felt like stepping into a paradise. With energy and resources suddenly abundant, evolution accelerated. Life that had been constrained for so long now had the means to experiment. cells linked together into more complex structures. Bodies developed skeletons for protection, eyes for hunting and mouths for feeding. This explosion of diversity may never have happened without the crucible of the ice ages. Snowball Earth had stripped life down to its barest essentials, leaving only the most resilient lineages. Those lineages, forged in the fires of hardship, were uniquely suited to thrive in the abundance that followed. The stresses of the deep freeze may have been the spark that ignited complexity. The reason why multicellular life did not just emerge, but flourished in dramatic fashion. The Cambrian explosion was not just about variety, it was about possibility. Entire body plans that still shape the animal kingdom today were established in those seas. The ancestors of worms, arthropods, mollusks, and vertebrates all appeared in that burst of creativity. Without it, the evolutionary path that eventually led to fish, amphibians, reptiles, mammals, and humans might never have unfolded. To think of it in human terms is staggering. Without Snowball Earth, without the hardships of those frozen millions of years, there might never have been the complexity necessary for intelligence to arise. No forest to walk through, no animals to paint on cave walls, no humans to look up at the stars and wonder. The very existence of thought, of consciousness, may trace back to the silent endurance of microbes huddled in the darkness beneath glaciers. The Cambrian explosion is often seen as life's great awakening, a sudden bloom after billions of years of simplicity. But in truth, it was the culmination of trials that came before, of bottlenecks that stripped away the fragile and left only the resilient. It was the reward for survival in the face of impossible odds. The Earth had pressed life against the edge of extinction, and life had not only endured, it had emerged stronger, ready to take on shapes and forms that would define the rest of history. The seas of the Cambrian would have been a dazzling sight, filled with creatures never before imagined. Trilobites scuttled across the ocean floor. Worms burrowed into the sediment. Spiny predators drifted through the currents, while soft-bodied grazers fed on algae. Eyes glittered for the first time in the seas, watching, hunting, surviving. It was a world alive with color, movement, and competition, a world born out of the silence of Snowball Earth. The tale of Snowball Earth does not belong only to our planet. It is also a window into the possibilities of life beyond our world. When we look across the solar system today, we see other icy bodies that seem cold and lifeless on the surface. Yet beneath their frozen crusts may lie oceans as vast as Earth's. The survival of life through Earth's own deep freezes offers a powerful lesson. If microbes could endure for tens of millions of years beneath ice here, perhaps life could also persist beneath the ice of distant moons. Two of the most compelling examples are Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. Both are small compared to Earth, yet each is wrapped in ice so thick that their surfaces gleam like frozen mirrors. At first glance, they appear silent and barren, much as Earth would have looked during its snowball phases. But scientists believe that beneath those icy shells, liquid oceans remain, kept from freezing solid by the heat of tidal forces and internal geology. Just as Earth's hidden volcanic vents nurtured life in the dark, these alien oceans may also harbor the chemistry of survival. Europa's surface is marked with cracks and streaks, long scars etched into its ice by the stresses of Jupiter's pull. Beneath that shell, an ocean may extend for tens of miles in depth, containing more water than all of Earth's seas combined. If that ocean is real, it is shielded from the vacuum of space by its icy lid, yet stirred from below by volcanic activity and chemical mixing. For life, that combination could be enough. Earth's microbes thrived in vents where heat and chemistry replaced sunlight, and the same might be possible on Europa. Enceladus, though smaller, has already given us even more tantalizing hints. Geysers burst from its south pole, spraying plumes of water vapor and ice crystals into space. When spacecraft have passed through those plumes, they detected organic molecules and salts, the same ingredients that make up Earth's oceans. The tiny moon is venting its hidden sea into the cosmos, whispering of an ocean beneath its crust. If there is volcanic activity at the seafloor of Enceladus, as many scientists suspect, it would create the same conditions that sustained Earth's earliest survivors: chemical energy in a sunless sea. Snowball. Earth shows us that ice does not always mean lifelessness. During the Sturtian and Marinoan glaciations, Earth was locked in ice from pole to equator. From space, it would have looked indistinguishable from Europa or Enceladus, dazzling white and silent. Yet beneath its frozen surface, life endured, clinging to hydrothermal vents, geothermal pools, and chemical oases. What appeared dead from afar was, in truth, still alive. This is why we look to icy moons with such fascination. Their surfaces may conceal secrets just as Earth's ice once did. It is a profound thought. Somewhere beneath Europa's ice, microbes may gather around vents, building mats of life that glow faintly in the darkness. Somewhere in the oceans of Enceladus, strange chemistries may weave chains of molecules, forming the first fragile steps toward living systems. These worlds may be laboratories of survival, echoing what happened on Earth nearly 700 million years ago. When we study Snowball Earth, we are not only uncovering our own history, but also testing a blueprint for survival in the cosmos. We are learning that life does not need warmth from the sun, that it can persist in darkness if there is energy and chemistry. The lesson is simple but powerful. Where there is water, where there is heat, where there is the possibility of reaction, there may be life. Earth itself proves survival in the unlikeliest of places. The fact that our planet looked like a frozen exoplanet, yet secretly kept its story alive beneath the ice, should make us cautious about dismissing other frozen worlds. What looks lifeless from a telescope may only be hiding its resilience below the surface. The echoes of Snowball Earth reach far into the solar system, reminding us that the struggle of life is universal, and that endurance in the face of impossible odds may be written across many worlds, not just our own. The tale of Snowball Earth might sound like something out of myth, a story too strange to be true. Yet the evidence is not hidden in imagination, but in the very bones of the planet. Rocks, silent and ancient, carry within them the fingerprints of this deep freeze. They whisper of glaciers that reached the tropics, oceans that vanished beneath ice, and life that endured in secret. Every stone that scientists split open, every cliff face they study, is a page in the oldest book ever. Written, one of the clearest signs comes from dropstones. These are chunks of rock, often large and out of place, found buried in layers of fine sediment where they do not belong. The only way they could have arrived there is if they were carried by ice. A glacier would grind a stone into its belly, hold it tight as it floated in an iceberg, and then release it when the ice melted into the sea. Today, dropstones are found in cold regions like the Arctic and Antarctic. But the strange thing is, during Snowball Earth, they are found in rocks that formed near the equator. That means glaciers were not confined to the poles. They stretched all the way into the tropics, dragging stones with them and dropping them into warm seas that should never have known ice. These scattered stones, frozen in place for hundreds of millions of years, are proof that the Earth was once wrapped in glaciers from edge to edge. Other evidence is locked in chemistry, in isotopes that act as subtle markers of ancient conditions. Carbon isotopes, in particular, reveal changes in how life and the environment interacted. During the frozen ages, the ratios of these isotopes shifted dramatically, showing that the normal cycles of life had nearly collapsed. Photosynthesis slowed to a whisper. Yet the isotopes also prove that it never ceased entirely. They carry the faint signature of microbial survival. The breath of life recorded in stone even when the surface world was locked in silence. These microscopic fingerprints are delicate, but they are undeniable. They tell us that life clung on, not everywhere, but in rare sanctuaries waiting for the ice to pass. Perhaps the most haunting clues of all are the layers of carbonate rock, known as cap carbonates. These appear directly above glacial deposits, forming a sharp boundary between ice and thaw. They were laid down rapidly when the world emerged from its frozen prison. As the glaciers melted, the oceans filled with carbon dioxide that had been trapped in the atmosphere for millions of years. That sudden flood of greenhouse gases caused a chemical storm in the seas, precipitating vast amounts of carbonate that settled as thick, distinctive layers. These rocks are global, found on every continent, and they mark the exact moment when the Ice Age ended. They are like a geological exclamation point shouting across time that the Earth thawed in a violent and sudden release. For scientists, piecing together these clues is like reconstructing a puzzle with most of the pieces missing. Dropstones tell of glaciers reaching the equator. Isotopes whisper of survival in hidden corners. Cap carbonates reveal the drama of the thaw. No single piece is enough, but together they form a picture too consistent to ignore. Across continents and oceans, the rocks repeat the same story, as if the Earth itself is determined to remind us of the trials it once endured. The evidence is not gentle, nor is it vague. It is stark and physical, cut into cliffs, scattered in sediments, etched into isotopes. Together they leave no doubt that the Earth was once a snowball, that life endured its silence, and that the scars of that age remain written in stone. When we think of Snowball Earth, it feels like a story that belongs only to the distant past. A frozen nightmare locked away hundreds of millions of years ago. Today we look around and see a planet moving in the opposite direction. Instead of ice advancing across the continents, glaciers are retreating. Instead of oceans sealed under us, miles of ice, seas are rising as the world warms. Yet the very same forces that once plunged Earth into silence are still present, still at work, and still capable of tipping the balance in ways we may not expect. The haunting question lingers: could it happen again? At first glance, the answer seems impossible. Earth is heating, not cooling. Carbon dioxide levels are climbing, not falling. Human industry has pumped vast amounts of greenhouse gases into the sky in only a few centuries, enough to overwhelm the slow, natural rhythms that once ruled the climate. The planet today is moving away from the conditions that created Snowball Earth. And yet, climate is not a simple machine. It is a balance, fragile and unpredictable, capable of flipping from one extreme to another with startling speed. Theoretically, if greenhouse gases were to collapse rather than increase, Earth could still find itself pushed back toward the edge of ice. Carbon dioxide is not simply pollution. It is a key part of the atmosphere's ability to trap heat. Without it, warmth slips away into space and the Earth cools. If for some reason the concentration of greenhouse gases were to plummet, the same runaway cycle that once gripped the planet could repeat. Ice would advance, reflecting sunlight back into space, and the cold would deepen with each passing year. What could cause such a collapse? In the ancient world, the breakup of supercontinents exposed fresh volcanic rock that absorbed carbon dioxide from the atmosphere like a sponge. The process of weathering slowly stripped the air of its greenhouse gases, pulling the climate toward catastrophe. In theory, something similar could happen again if new continents rose, or if vast new mountain ranges were exposed to rain and erosion. Even now, carbon dioxide is absorbed by rocks and oceans, though not at the scale required to trigger a global freeze. But the principle remains: remove enough greenhouse gases, and even under a stronger sun, the Earth could slip once more into the ice. What makes the idea so haunting is not its likelihood, but its reminder of fragility. The balance that sustains life is not guaranteed. A few changes in the wrong direction and the seesaw could tip. Today we are pushing it toward heat, but the same knife's edge could in another age tilt back toward cold. The Earth has already shown us that it is capable of both extremes, that it can be a greenhouse world or a frozen tomb, depending on the smallest shifts in gases, sunlight, and geology. Imagine if our ancestors could have seen the cryogenian ages, when glaciers smothered the tropics and the oceans froze to their depths. They might have thought the planet was uninhabitable forever. Yet the balance eventually tipped back. Volcanoes and greenhouse gases pulled Earth out of the freeze. Life survived, but only barely, passing through a bottleneck so narrow that extinction hovered constantly overhead. Now, we are the ones pressing on that balance, not with geology unfolding over millions of years, but with factories, cars, and cities altering the air in just a few centuries. It is astonishing to realize how quickly we have shifted the atmosphere compared to the deep past. During the cryogenian, it took millions upon millions of years of rock weathering to strip enough carbon dioxide to trigger a global freeze. In our age, in just a few hundred years, human industry has raised atmospheric carbon dioxide to levels not seen in at least 3 million years. The scale of change that once demanded continents breaking apart and volcanoes erupting endlessly has been matched by the burning of coal, oil, and gas. That speed is what makes our moment so precarious. The planet can adapt slowly, but when changes come too quickly, the balance breaks. The lesson of Snowball Earth is not only about ice, it is about fragility. It shows that life on this planet has always been vulnerable to climate swings. It survived the frozen ages only by clinging to refuges. And when the thaw came, it was transformed. For us, the warning is clear. If we continue to push the climate further into imbalance, we may survive, but what emerges may be unrecognizable, with ecosystems collapsing, coastlines shifting, and entire ways of life forced to adapt. Snowball Earth reminds us that stability is not guaranteed. The balance can be broken. And just as the glaciers once reached the tropics, our choices today could set in motion feedbacks that reshape the world for generations to come. The frozen ages show us that the Earth does not forgive imbalance easily. It reacts, it amplifies, and it transforms. What is at stake is not the planet itself. The Earth will endure, but the thin layer of life, including us, that depends on its fragile equilibrium. When we look back at Snowball Earth, it's tempting to feel a sense of security, knowing the planet escaped its icy tomb. The glaciers retreated, the oceans reawakened, and life eventually flourished. But it's worth pausing to imagine the darker possibility the path history almost took. What if the Earth had not thawed? What if the volcanoes had fallen silent, greenhouse gases had not built up, and the sun's faint warmth had never been enough to tip the balance back toward life? The answer is chilling. Life would have ended with microbes, tiny organisms clinging to volcanic vents and chemical oases, trapped in darkness until the last sources of energy flickered out. There would have been no plants reaching for the sun, no animals crawling, swimming, or flying across the planet. The vast evolutionary story we know would have been cut short in silence, erased before it began. Picture such a world. The Earth remains sealed in white, its continents buried beneath miles of glaciers, its oceans black and starved beneath unbroken lids of ice. From space the planet shines like a frozen pearl, dazzling and lifeless, a perfect snowball drifting in the void. On the surface, silence reigns. No rivers cut through valleys. No rain falls from the sky. The air is thin, bitterly cold and empty of sound. Beneath the ice, life persists for a while. Microbes cluster in thin mats around hydrothermal vents, where heat and chemicals rise from the planet's restless interior. They feed on sulfur and hydrogen, reproducing slowly in the dark. But their world is small, fragile, and finite. Without circulation, the oceans stagnate. Without a thaw, oxygen never surges back into the seas. Without sunlight, photosynthesis never expands again. Slowly, over unimaginable spans of time, even these refugees would fail. The deep freeze would tighten its grip until not a single living cell remained. No plants would ever spread across the land. The continents would stay barren, their soils locked under ice. No green forests would breathe oxygen into the atmosphere. No flowers would bloom. No roots would split stone. No seeds would scatter on the wind. The air would remain thin, empty of the richness that makes breathing possible. No animals would ever appear. There would be no trilobites scuttling across the ocean floor. No fish darting through shallow seas. No reptiles basking on rocks. No mammals huddling for warmth. The seas would remain silent, the land forever bare. The Cambrian explosion, that great bloom of diversity, would never happen. The path toward eyes, skeletons, wings, and brains would never begin. Evolution's canvas would stay blank, its colors never painted, and of course, without that explosion of life, there would be no humans, no hands to carve tools, no voices to sing or speak, no minds to wonder at the stars. There would be no history, no memory, no stories. The Earth would be a frozen monument to what could have been, a reminder of how close the story of life came to ending before it had the chance to unfold. This alternate world is not just a thought experiment. It is a glimpse into a fate that was possible, perhaps even likely. The planet was caught in a trap that could have been permanent. Only the slow, patient breath of volcanoes releasing greenhouse gases into the sky pulled it back from the brink. Without that fragile escape, Earth would have joined the countless frozen worlds we see in the cosmos, planets that may never have had the chance to spark with life at all. It's humbling to think how narrow the margin was. Our existence depends on a delicate balance that nearly failed. Had the glaciers never retreated, we would not be here to ask these questions, to imagine these histories, to look back on a frozen world and call it our past. The Earth would still be there, silent and shining, but its story would have ended, with microbes whispering in the dark. For 60 million years, the world was locked in a prison of ice. Entire continents were buried beneath glaciers. Oceans lay sealed beneath frozen lids, and the skies themselves were stripped of clouds and rain. By all logic, life should have ended there. The odds were impossibly small, the conditions unimaginably harsh, and yet, against all reason, life endured. This endurance was not grand or dramatic. There were no great forests standing tall against the cold, no animals clawing through the snow to find shelter. Survival belonged to the unseen, the smallest and simplest forms of life, hidden in places where warmth and chemistry still lingered. Microbes huddled in the shadows of hydrothermal vents at the ocean floor, feeding on the minerals that gushed from the Earth's interior. Others found refuge in geothermal pools where volcanic heat kept tiny sanctuaries alive. Some may have endured in thin cracks of open water near the equator, where ice was thinner and light still barely touched the sea. Generation after generation, they clung on. Each cell carried forward the thread of existence, dividing and multiplying, adapting to the eternal night. They faced shortages of nutrients, fluctuations in heat, and endless time without the comfort of sunlight. Yet they endured because to survive is the most basic drive of life, written into the very chemistry of every living thing. It is staggering to think that every plant, every animal, every human today exists because of that endurance. The resilience, written into those ancient microbes, did not vanish with the thaw. It is written into our DNA, the ability to adapt, to withstand hardship, to continue when conditions seem impossible, is not just a story of the past, but a living inheritance. Every breath we take carries within it the triumph of those long-dead cells that refuse to disappear in the dark. Imagine tracing your family tree back, not through centuries or even millennia, but through hundreds of millions of years. Each branch would narrow and narrow until it reaches those microscopic survivors. They are our ancestors just as surely as our grandparents and great-grandparents are. Without them, there would be no forests, no oceans filled with fish, no birds in the skies, no humans to wonder about the stars. We are the children of survivors.
Of ice. The miracle lies not only in the fact that life endured, but in how it emerged stronger for having endured. The hardships of Snowball Earth acted like a crucible, forging resilience.
When the thaw finally came, those survivors were ready. They had endured scarcity, so abundance pushed them into new forms. They had adapted to darkness, so sunlight gave them room to grow. Their resilience prepared them to take advantage of the new world, leading to the burst of diversity that followed, and eventually to the rise of creatures with eyes, bones, wings, and minds. Even now, when we look at life around us, we see traces of that survival. Microbes that thrive in volcanic vents or boiling springs are echoes of their ancient cousins, reminders of what life is capable of. The genes that allow humans to adapt to heat, cold, altitude, and scarcity are part of that inheritance. The resilience that allowed life to survive 60 million years of frozen silence still whispers in our biology. Proof that we are not just fragile beings, but the outcome of unimaginable endurance. The story of Snowball Earth is not just one of catastrophe. It is a story of persistence, of survival in the face of certain doom. It shows that even in the most hostile conditions, life can find a way to continue to adapt, to endure. And it is because of that miracle carried forward through time that we stand here today, breathing, thinking, and remembering the silence of ice that nearly ended everything. When we look back across the history of our planet, it is easy to forget just how improbable our existence truly is. Earth has been through fire, through floods, through extinctions, and through freezes so complete they nearly silenced life forever. Yet among all of those trials, none stand out quite like the age of Snowball Earth. For 60 million years the world was locked in ice. Entire oceans were sealed beneath glaciers, skies lost their clouds, rivers lost their flow, and continents lay smothered in frozen silence. By all rights, life should have ended there, but somehow it did not. That survival is nothing short of impossible. Against crushing cold, against starvation, against a night that lasted longer than humanity has even existed, life endured. Tiny microbes hidden in cracks of warmth beneath the ice carried forward the thread of existence when everything else seemed lost. They survived not for a day or a year or a century, but for tens of millions of years. They endured conditions that would destroy almost anything we know today. And from that fragile survival came everything that followed. forests, animals, oceans,
alive with colour, and eventually humans. The fact that you and I are here at all is because Earth thawed, because volcanoes breathed out gases that warmed the skies, and because those tiny organisms held on long enough for renewal.
Without them, there would be no plants to paint the continents green, no animals to swim or run or fly, no people to wander at the stars or to sit quietly listening to this story. Without the miracle of survival beneath the ice, there would be no us. It is humbling to think of ourselves as the descendants of survivors who clung to life in darkness. Written in our DNA is a record of resilience, the echo of endurance through impossible odds. Every breath we take, every thought we form is only possible because life refused to give up in an age when the planet itself seemed determined to erase it. Snowball Earth is not just a chapter of catastrophe. It is also a chapter of hope, reminding us that life can bend without breaking, that even in silence and ice, persistence is possible. And so I leave you with a question, one that is both haunting and personal. Would you have survived Snowball Earth? Could you have endured a planet sealed in frozen silence with only the faintest cracks of warmth to cling to? Perhaps the truer answer is that you already have, because inside you is the inheritance of those survivors. Their resilience is your resilience. Their triumph is your triumph. You are here because they whispered against extinction and carried the story forward. If this journey through Earth's frozen past has stirred your imagination, if you find comfort in exploring these impossible stories of science with me, I would be so grateful if you left this video a gentle like and maybe tapped subscribe. It helps this quiet corner of the internet reach more curious minds, more dreamers, more people who love drifting into the mysteries of our world. And if you feel called, share in the comments where you're listening from tonight and what time is it there. I love seeing how far these soft journeys travel, how we are all connected by the same story, even when scattered across the world. So take a deep breath. Let your shoulders soften. Let your eyes grow heavy. And carry with you the wonder that we are here not by chance, but by the miracle of survival. Life endured 60 million years of ice. And because of that, you are here breathing, listening, dreaming. The story continues. And together we will keep exploring the impossible. Sleep well, traveler.